Welcome everyone. Thank you for joining us today on our on this Water Talks. This is a Pass the Mic edition. So we've got a team here with Barge Design Solutions, and he's going to be taking us through a little look at InfoSWM and some of the kind of basics in it, and just some overall good modeling practices. So if you want to flip to the next slide. My name is Ryan Brown. I'm a solutions engineer with with Innovise. And like I mentioned, we've got a team here with us today. And do you want to give us a little introduction of yourself, Adim?
Sure. I'm the practice leader for the collection system modeling and planning here at Barge Design Solutions. So covered the whole range of wet weather, collection system modeling, rehab design, and consent decree programs, flow monitoring programs, etc. I've been doing this for about I think this year is 20 years specifically in that area. I do have some additional background in groundwater modeling, etc., but that's not what we're talking about today. And I've been an InfoSWM user, I guess, for I want to say about 15 years or so now. And I'm by no means an expert on InfoSWM, but hopefully I can share some things of what I learned over the years and what we use to streamline the modeling process and get the results that are helpful for utilities to understand their systems.
Yeah.
Thank you, Ryan.
Absolutely. It sounds like we'll have some good experience to go over with it. So I'm gonna hit the next slide, and then I'll hand it off to you. So yeah, if you haven't been to one of these before, it's a pretty simple concept where we're just kind of presenting on a topic, and if you have any questions or comments or anything you want to share with us, only the team and myself will see those questions. So please feel free to ask any and all questions, and we'll get to them as we can fit them into the presentation. We do have some nice upcoming water talks next Wednesday. Next Tuesday we won't have one, but next Wednesday we do have I guess you could call it a 2-hour-long special of some different case studies from the public utility side, from the private sector, as well as academia. So should be some good topics, some good things to look after. And then the following Tuesday on the 14th, we have one focusing on water leakage assessment. So, and that'll wrap us up for the rest of the year until we get to January next year. But with that, I'll hand it over to you, Hatim, and you can take over the bulk of the presentation.
Thank you, Ryan. Again, Hatim El-Saig with Barge Design Solutions, and I'm happy to share some thoughts on how we use InfoSWM for collection system modeling today. I hope it will be beneficial to you. For today, we're starting always with leveraging existing data. What data do you have, and where do you start? What do you do before you even start building your model? Some thoughts on that, some best practices. Using the GIS Gateway within InfoSWM, which we have found very helpful. Setting up some user preferences, talking about the operational data, setting up simulation options. We'll cover some of those. Talk a little about calibration, validation, and then concluding with evaluating alternatives and some final thoughts, more to do with improving continuity errors, if you will. So it's a cliche of is it an art, is it a science? And it is if you have the right science. Basically, I won't get into differential equations or equations, but the Saint-Venant, if you have them set up right, if you have your science correct, excuse me, and you have the tools to enable you to use that science, which is the modeling tool and the all the facilities that are available within this, then it becomes sort of an art after that. What do you want to display? How do you want to display it? But it's important to have the science correct, to make sure you have a software that's grounded in the correct hydraulics, the correct solutions of the equations, and enable you to manage those solutions and have the tools to not interpret, but simulate your system assets correctly in terms of conduits, manholes, orifices, weirs, outfalls, pumps. You know, what's available under the pumps and how they operate, all of that. So it's all three, but you have to have the right science, the tools, and then you can be sort of artistic with it. So leveraging your existing data for developing the network. And almost everybody these days, you know, maybe 15, 20 years ago, you know, not everybody had GIS, but I think everyone now has the GIS database as a starting point. I know, and I know, you know, whenever we start a project, it's almost always you hear from whoever the owner is, like, yes, we have all the GIS database, you know, we have all of that. What does it take to develop a model from it? And almost invariably, you know, you will find that the GIS database is lacking. You know, there are a few who would have it populated correctly, but there is always some additional work, and it's good to understand all of that before you start modeling. We, myself included, you know, are excited. It's like, let's import this data and start building that model and running it. No, let's take a deep breath. Let's look at what's in the database, look at what's available in terms of resources. You know, I wrote here drawings, not as-builts or record drawings, because, you know, you have the as-builts, the as-plans, the as-whatevers, really is what I've learned. And so you need to understand what's available as well. Sometimes there are operation maintenance records that may have additional information that's not in the GIS database, for sure. And then there is whatever there is condition data that can give you some insight into pipes where debris, for example, or deformed pipes, or, you know, places where there are intruding laterals, etc. Those all compromise the circularity of the pipe. You know, when you use InfoSWM or any software for that matter and say circular pipe 8-inch, it's going to be exactly 8-inch circular pipe. If the condition in the field varies from that and you don't represent it in the model, then you'll have deviations in your solution, and you can't represent every single condition, but there are some that are significant enough that need to be understood. So understand what's available to you before you start building the model, I guess is the point I'm making here. In many of you, if not all, understand this, so I'm reiterating it at this point. So before we start importing infrastructure data, and now I'm going to focus on GIS specifically, create a separate model import geodatabase, because you're going to be dealing with this and manipulating it, and there are things that may change. So preserve your original database somewhere and create a copy separate model geodatabase. Check for uniqueness. You will need the pipe ID, the manhole ID. You want to import, when you import your data, you don't want to overwrite assets, and we'll see this more when we get into the GIS Gateway. But ensure you have a unique ID for your assets in each set, in terms of pipes, in terms of manholes, in terms of pumps. So when you import, you don't overwrite anything. Dimensions is another thing that we've come across, and sometimes the dimension will be numerical, So you would import straight an 8 or a 10 or a 12 into the model, but sometimes it may have the quote as 12 inches or 8 inches, or sometimes it's text, sometimes it's hyphenated with inch, and you want to make sure that the dimensions are all numerical so you can import them easily and they would populate. Of course, you can change them once you import them into the model, but it's much easier to clean all this up and make sure it's populated and what you're going to do with blanks before you start importing into the model. Because once you import to the model, the amount of work that it requires to repair and go back and fix it increases with the complexity of the model. And I already alluded to where you have blanks. What are you going to do with missing data? Are you going to populate it before you import it? Are you going to populate them and deactivate them? And we're going to talk about the facility manager later. And we've done this a lot, especially when we have terminal areas. Let's see a subdivision that's way upstream into the system, and there is nothing coming into it, but it is the starting point. But we don't have enough data on it. It's a new subdivision or very old and was annexed. So we would still import it, but deactivate it in the model until they complete the survey. This way, we're not delaying the development of the model, but we acknowledge that there are facilities that are incomplete in terms of data. Now, if it's in the middle of the system, you want to do something different, like interpolation, or actually go and survey that because you're creating gap in the middle of your system. But if it's terminal, nothing flows into it, you can deactivate it and move on until you have the rest of the data.
Yeah,
so,
and I know there are some. I was just going to add. I know there are some user fields and things like that, so you can help to track, which values were maybe brought in through interpolation or other things like that. Did have some good feedback from Bob Dickinson already regarding the unique ID, and that is a very critical piece of it, and especially without including spaces necessarily within that. I would imagine really any value or whatever that you're putting in, just because of how ArcMap interacts with spaces sometimes and things like that. He did have a question, and I don't really know the major difference between the two, but do you have a preference between a file or a personal geodatabase when you're managing data?
I typically use whatever I'm given, but yes, it's been mostly shape files that we've added, if that is the question.
Okay, rather than managing it as a
yeah
database.
We've done both. It's really, honestly, Ryan, most of the time is whatever we receive from the client or from the utility. We try to be flexible. We do request a geodatabase, but if it's not available, if it's easier for them to send the shape files, that's what we would go with. Gotcha. If that helps, if that makes sense.
Yeah, I mean, I would do the same thing. I know there's advantages to file and personal geodatabases over just the shape files, but I'm sure as you're, just looking over the data and cleaning it up and things like that, you can take care of some of that.
Yeah, if we'll ask for a geodatabase, and if we get the question is like, what's the geodatabase, or what do you mean, then we'll go with shape files.
Yeah, it just makes it easier for everyone. So
yeah,
but that was it. Sorry to interrupt.
No, that's fine. And I guess I should have said, feel free to interrupt, and hopefully Bob doesn't have too many questions for me that he can answer. Anyway.
Challenging.
Okay, but yes, please chime in at any point. I'm just sharing my experience and my exposure to it. It's by no means comprehensive. I really like the GIS Gateway, and in terms of to me, it's the mapping tool. And when you open the GIS Exchange cluster, there is an icon. It allows you, to set up, what Exchange cluster are you adding? Is it what you see here is a junction, a conduit, outfall pumps, whatever it is. You set it up to import the data, and that's your chance. Naming, make sure you have informative names, I guess, if you will. And again, I think it was mentioned already, don't leave spaces, use dashes or underscores to make the name make sense. And I don't remember about the case with the Exchange cluster, but I know once you create a conduit or a node, you cannot change that name. You would have to delete it and recreate it if that is the case. You can change the description that's after the comma. So make sure you have a good naming convention, good naming process as you start. That's always very helpful, because I'm not somebody who likes to end up with conduit or CDT-1-2-21. I'd like to use the IDs to the extent possible. Once you get in there, it'll give you the option here. You have a junctions table, and you would specify which file the GIS data is coming from. Sorry, this is covered. I didn't remove it, but it will have the GIS data fields right here. And you would have the corresponding, or not yet corresponding, but the InfoSWM fields available for a junction. So the manhole goes to a junction table, and here is where you map each field that you have into one of the junction. Of course, you'll have extra fields in GIS and some in InfoSWM that you're not going to use, like you might not have year of installation, and it doesn't have any bearing on the simulation. But in terms of the XY, it will determine your location, your position, so you can have it correctly on the map. There are the user tag where you can add information of where missing data or this is inactive until data is collected. But then the most important, or the important things are the elevations, the invert elevation, the rim elevation, etc. You just make sure you map them correctly. And the first time you're bringing them in, you're creating new records in this case. But once you create them, and if there is an update to that shapefile, you can update existing records, and that's where the ID is important. Or if you have a new set and you want to delete that records that are not existing, you have several options basically here. So if you see here, there are several tabs, 3 tabs: table join, the spatial join, and the field mapping. And I've always used the table join. Basically, that's why the ID is important to me. And what we're saying is in this case, it's the Conduits table. The tabular join is on the facility ID. That's what my unique ID is, and that's what I need to check before I start the import, before I move into the model. And then after that, we start with the field mapping once we know which ID. And so if you've already imported part of the database and some additional data was added to it, but the unique ID is still there, you get a new one from the owner of the data, then this just note that reminder to update, to make sure you're updating existing data rather than overwriting something. Because just a case here, you might have corrected all the diameters which were in text, for example, 8-inch whatever, and imported them, and now you have or updated some inverts in the model, because after you imported, you look at drawings and you fix those inverts. You don't want to reset those to what was in the GIS originally. You want to add the new fields only and keep what you already imported. So that, I think, before I move off of the GIS exchange, Ryan, do you have any comments? Any add?
Yeah, I was just gonna add in some things that we're getting from Joshua in the audience about maybe some of the reasons you might pick the personal geodatabase versus a file geodatabase, and that personal databases aren't supported in ArcGIS Pro. So if you're using that to manipulate any of the data, you could run into some problems there. And then also a note on the unique ID, and that, you know, it is kind of the record keeper, but underneath utilities and change ID tool, there is an option to be able to change those from the existing old one into a new ID. So there is a possibility of changing that, whether it's that convenient to have to key in all that information. It could be kind of a pain to do it within the change ID tool, but at the same time, it is a capability. But, yeah, and that's all I got. So keep going.
Okay. Next is a note on network connectivity. You know, you've imported. Obviously, I would strongly recommend, I don't know, there's a way around it, just the junctions first, set up your manholes, and then you hopefully you have the start and stop manhole defined in your conduits table in GIS, and this way you connect them correctly as you import the pipes. So import the manholes. If there is ever a question about that, always start with the manholes. And then I like the tracing tool. I really like the tracing tool where you select a manhole and trace upstream, make sure everything is connected, and you know, depending on your setup, InfoSWM will turn everything that's selected or traced into red. I mean, you can change those colors, but selected is red, and just normal model conduit is blue, and gray is inactive, and we'll get to that. But if you see a disconnection, if you see, you know, the network is tracing red and suddenly it's blue, you know that there is a disconnection there. And to me, as a visual person, I like to look at maps. It tells me directly right away where I have a disconnection. So I like and I highly recommend using the tracing tool right after you build your network, just to make sure everything is connected. And you can start from the outfall and make sure everything is traced, or certain sections that you're studying, depending on how big, how complex your model is.
Yeah, and I think that emphasizes too, just, you know, the data side of things, of bringing things into a model and making sure that within the you know, you bringing in that node data first, and then making sure that you have in the pipe network records the IDs that it's connected to ensure some of that connectivity. I guess I can mention too, you know, in addition to the tracing tool, there are some orphan node and orphan pipe pieces. So at least you could find orphan ones, but of course you wouldn't be able to notice where there would be maybe a small gap in between two of them. But I do believe there's, when you go through the validation in the run, it will point out if a node or a pipe isn't connected to an outfall, which is a requirement for the model. But
yes,
good stuff.
Thank you. Yeah, I forgot, I guess, to include the orphan node, but that's another function that we've used. I just like the visual tracing.
Yeah.
You can always as well reverse. Sometimes the pipes in the GIS are drawn backwards, and you can put arrows on them in the GIS and trace the direction. But if you end up with those in InfoSWM, you can always reverse them. Reverse the direction, redraw the link, and say this is the start stop node. I like also to draw profiles sometimes if the model is not, I mean, let's say I have a model with a couple of major trunk lines and it's more of a skeletal model. I would go ahead and plot the profile of those lines and just make sure it makes sense visually, you know, it makes sense on the screen, because that will get me to a point of, okay, you know, there is an obvious node missing invert, you know, it's set to 0 for some reason, and you'll see the drop on the profile or some negative slope. You'll find those quickly. You'll learn that more and more. I'm a visual person, and that's what a lot of the tools that I like are in that direction. So the fixing the network connectivity as well, the review. You always need, I think we alluded to this, start and end nodes are required attributes for all model links. You have, when you open the conduit table, you have to have a start and a stop. So when paired with invert data, it dictates the pipe direction and the slope. And if the start or the start and stop node of each pipe, if it's not imported in GIS, the link connectivity can be filled using the fill link connectivity. That's a functionality there, which is based on the spatial relationship of the link and the node once you have them there. And so I'm sometimes when you're going along, just like we're doing this presentation and talking about it, something will change, something will happen, and that's the subject of my next slide. And I did discuss this with Ryan before the presentation. When the model crashes, it's not of what if. I mean, something you'll do, something will crash. So it's okay. You know, that's the interruption right here. Don't panic. There is a very nice way. Just what I would say is, don't go to another model. Don't try, it's like I'm gonna go do something else right away. What I do, even if I don't have time and it's like crashed at the last minute, I'll reopen it, and it'll tell me this very nice window will come up, and I've never used anything except claim the detected session, because it'll tell you that there is a detected session that crashed. I'll go claim that session right away and save, and then I can go do whatever if I'm short on time. But I would, at least for me, I would not let it go. I would not, okay, it crashed, I'll just come back to it later. No, I'll go claim that session, save it, because it'll be a point where you left it, and then move on. All right. Anything on that, on maintaining?
Yeah, I think that's generally our recommendation as well. You know, especially if you're trying to you know, get that, because and it looks like Bob's kind of guiding us here that there's a backup in the temp directory where that's you know, getting the edits and things like that you need. Of course, if you crashed on a situation that you didn't want to save your edits, maybe you would disregard and overwrite the session.
Yeah,
but,
yeah.
I think for the most part, claim it.
I never made edits that I didn't want to save.
Yeah, I don't think many people do.
No.
Or try not to.
Thank you. Yeah. No, thank you. I appreciate that. It's good input. All right, so we recovered our model and it's working fine now. So we move on. We've built a network. We have it connected. We have the proper ID, start, stop, start and end for each conduit. And we have a continuous network connected to an outfall. The next thing, and another thing, you know, I like is the project preferences, or setting up the user preferences. There are a lot of things. I'm just going to touch on a couple of them that to me I have found helpful, and Brian, Bob, others can chime in with preferences from your experience that may prove valuable. Just the auto length calculation. If you don't want to import the length, it will allow the length calculation once you connect any two nodes with a pipe. You can always override this. I'm pretty sure with the length that you specify. There is also the store absolute conduit invert. So in InfoSWM you can designate an offset or use an offset. So if the manhole invert is whatever 200 and you say the offset is 1, then the invert of the pipe at this node will be 201. I like to see the invert myself, so what I like to do is set it to the absolute conduit invert and the store the absolute junction rim, so I know what the ground elevation for the junction is and what the conduit invert is, rather than a relative. This invert is offset by 6 inches above the invert of the pipe, for example. So I talked about the auto length. You can uncheck it if you want to import the GIS values. If you're comfortable with what's already in your shapefile or in your geodatabase and you're just importing that as the length, then you can go ahead and uncheck that.
Yeah, it looks like we got a comment from Bob on that.
Sure.
That the offset is important because the GIS data is normally absolute, but the default is depth. So just making sure that all that kind of lines up.
Okay. Okay. Yeah.
Or as you expected, I guess.
Mm-hmm. Thank you. Next, which I consider time savers. So here you can set the prefix you want. If the utility you're working with, let's say, has 2 basins you're modeling, and rather than naming, I'm just going to pick a simple one, junction by JCT. You can say, it's like Big Creek, BC is the basin, or Yellow River YR. So you can change the setup, the prefix for how you name your manholes, and it tells you what is the next number. So there is already up to 141 junctions here. Conduit is the same thing. If you want to change the prefix into something related to a basin or related to a facility or the treatment plant that's downstream, whatever it is, I think this is something that's helpful to just know where you are, and it's more valuable, obviously, in more complex models as opposed to when you just have one basin and you know where everything drains, one outfall. And those are the pointers on the preferences. Anything here I want to give you a chance, Ryan, if you want to chime in, or it's good.
No, I mean, I think this is one of those things that's nice to know. You can customize some of these things and do different increments. So like, I would think a good example is if you're building out a model, maybe a good idea would be to increment by 10, so that you can add in, different ones if you want to add nodes in between certain areas for whatever reason. Just some things to think about there.
Yeah, good point. And the other thing, I guess, is the other column, the description. You can change this to, rather than just saying new junction, if you're importing or building a model in one basin, you can describe it as this is the Bear Creek. I think every area almost has a Bear Creek or something like that. So you can change the default description. Of course, you can edit it, but I'm just saying if most of your default is of one point, again, that's why I called it time savers. Really doesn't affect your hydraulics. Let's see. Project preferences, operational data. So there is an operations tab with a lot of curves and a lot of data that you can build, and I really like this functionality. Usually on the right side with the InfoSWM browser, but typically, most systems have pump stations, and you want to be able to input that data from the pump curve, so that hopefully that's part of the operational data. We talked about GIS infrastructure, we talked about drawings, we talked about operational data, and that's where this comes in. So you define, you go under curves and you select the pump curves. As you see, there are some related to storage, diversion, tidal curves. If you have a discharge into a tidal water body, but for pump curves, the typical, most of the time, is what I use is the head versus flow. Just make sure your units that you're inputting. A lot of times we get GPM and we start inputting those values. If I have somebody who's starting with the model, a junior engineer, and sometimes I don't give them enough direction, or I just let them do it just to learn the lesson, memorize. You load this GPM and it's MGD, and you end up with a very different behavior. It'll work, but it's very different behavior. So just save yourself time, and if you need to do a unit conversion, do it ahead of time before you put those values in. And I like, again, the visual to the side. It's not just putting values in a table for the pump curve, but I also like seeing it and seeing that 0.3, for example, is not dropping down to 5 or something, but it looks like a pump curve.
And a question I have is, do you normally just use the manufacturer's pump curve and just kind of go with that? Do you do any kind of calibration, maybe deviated from that?
Very, very, very good point, Ryan. Thank you. We start with the pump curve if we have reason to doubt, or we know it's too old. We would do a lot of times we would request a drawdown test, and we would use some of those values to verify it. In some cases, when you do have a dense high resolution network of flow monitors and you can see the behavior, we might have to still adjust the pump curve in the model as part of the calibration to match the downstream output. But yes, that can be, we typically start with the manufacturer, especially if it's a more recent pump station. If we have reason to believe that there is wear and tear, or if the client, the utility, the operator says something to that effect, it never runs, we're never able to put out this or that, then we would request a drawdown test, or we would do it ourselves depending on our scope and use those values. But we would also come back and want to see that this pump curve produces the observed results at the next downstream flow monitor. And sometimes we would have to add some friction factors to account for fitting, head loss factors to account for some fittings. Sometimes you need to decrease the diameter, I guess, of the force main if it has accumulation inside of it. It might be 8 inches on paper, but it's really 7.5 or 7, so it can be part of the calibration.
We get a good question around pumps. So and I don't totally know the answer to this. I'm trying to look through the help files and might have to get back to you if you don't know the answer, team. But what's the difference between the 102 pump and the 104 pump in InfoSWM? They're both depth flow pumps, but
let me see if I can I'm gonna go to my InfoSWM. Of course, there is a risk here whenever start running a live model. Operations. Need to move this away. And curves and pump curves. Let's say a new one. Okay. And what is 102? Depth flow, head flow. I guess, well, to me, that the one is the depth within the wet well. The other is the head above the pump, the head that the pump is seeing. So
Okay.
the depth can
So
be,
one of them,
unless Bob has something else, the depth can be, you know, if the depth in the wet well is 3 feet above invert, this is the flow that's coming out, versus those 3 feet might be only 1 foot above the pump invert. Or actually the head is really the total head the pump is seeing.
yeah, so Bob's saying the 102 pump is on depth and the 104 pump is a dynamic head. And that 104 is a more common pump type. So,
but the head is what you will typically see. That, I mean, typically the head is what you always see on the manufacturer's curve. It's the head against which the pump is operating. So it total static plus whatever friction head loss, that will guide your pump to what it's pumping.
yeah, and I'm looking at the help menu, and it's saying the type 2, the 102, is an inline pump where flow increases incrementally with inlet node depth, and that the type 4 is a variable speed inline pump where flow varies continuously with the inlet node. So hopefully that kind of answers that question. And underneath the pumps in the help menu, there is a little more detail on that. So if you're interested in,
I think pumps and diversions are, sorry.
Good. Sorry, go ahead.
I was going to say, I think pumps and diversion structure are probably worth a presentation or a talk by themselves. It's just the wide variety there and things you can do.
Yeah, and I misunderstood a little bit between the 102 and the 104 comments from Bob, that between 102 and 104, it sounds like 104 is the most common between those two, but 103 is the most common overall. So
yeah, the 103 is I've always used it. Yeah.
The others. So hopefully that clears that up. I guess as long as we're on questions, I might as well bring up one that we had a little while back on converting data from a Civil 3D file into a shapefile, because, you know, as the name implies with the GIS Gateway, it's only GIS files that it's able to look at, so that's going to be tables and feature classes. However, converting from Civil 3D, I have a kind of good answer, but I don't know if you have.
I'm yeah, Civil 3D is outside my expertise. Okay. Usually somebody will convert it for me, so go ahead.
Yeah, so I'm not a total expert on Civil 3D necessarily, but briefly looking through it while we're sitting here, it doesn't look like there's anything really good to get it out of Civil 3D into an ingestible format like a shapefile or a geodatabase file. However, within the toolbox of ArcMap, and I would assume that means there's a tool within ArcGIS Pro as well, there is an option to convert a CAD file, a CAD data set, into a geodatabase. It's called CAD to geodatabase. That's in there. I don't know how clean it is or how well it converts that, but it does look like there is somewhat of an option to be able to do that kind of thing. And we did get some comments from the audience that a KMZ conversion is a good middle ground between CAD and GIS. I'm guessing with the KMZ file, you can maybe go from CAD to KMZ to GIS. I don't know if you want to confirm that, Kyle, but that's what I'm understanding. Oh, map export, to be able to export out from Civil 3D. I guess that's a keyword you can use within the command line of Civil 3D. So sounds like there's some different options out there to be able to help with some of the conversions. The KMZ file gives you worldwide coordinate system, those coordinates of the CAD file into a WGS 84 coordinate system. So I'm sure there's different creative ways you can do it. I don't think we have all the perfect answers for you, but there are some there.
Another good talk, file conversions for model building. I mean, seriously, there is
Yeah.
so much out there. As I said,
data management. Yeah, especially as we get more integrated with Innovyze gets more integrated with Autodesk and their products and things like that.
Yeah.
For sure.
Yeah. Good. Okay, I realize I haven't finished half the presentation at this point. Excuse me. So I'll try to run quickly through it. Time series, another thing about under operation, that's where I define my rainfall. Just again, make sure you have the proper time steps, whether your data comes in 15 minutes or 5 minutes or 1 minute, whatever, and the value, what values you're inputting in terms of inches, etc. Just that's where I like to put my rainfall for. Well, that is where I put my rainfall for wet weather simulations. You can also build a data file or have a data file and reference it from within InfoSWM. So it reads that data file as opposed to opening an Excel or a CSV and typing or populating the data in a table. So the data table for the rainfall can still be outside as a file, and you just link or point InfoSWM to it to read it. For dry weather flow, there is a for the node there is information, an inflow tab where you can put various types of inflow. And for the dry weather, I like to define a pattern that's based on the flow monitoring data, and that's a plugin. And flow monitoring, just typically not typically, when you choose your flow monitoring sites, try to the extent possible to have similar land use feeding into that meter, because that will simplify your pattern. You're not mixing so many patterns within one. So have a decent size, small enough, large enough so you don't have hundreds and hundreds of meters, but small enough to have a pattern that covers that area. And then you can build it and put the average flow. I like the functionality, and a lot of our clients, the utilities we do, would have a different pattern for weekdays and weekends, and I do like that the fact that InfoSWM has that functionality. Plus you can add on top of that, superimpose a monthly variation if you have tourism in the area, and your flow varies even monthly on top of that, on top of the hourly and weekday, weekend. And for wet weather flow, rainfall derived or dependent infiltration and inflow, we've used the unit hydrograph group, and that's basically it's an RTK, where R is the fraction of the rainfall that makes it into the sewer system, the time to peak, and K is the recovery or recession ratio of recession time to peak. So you build those three triangles basically here. You have the short term, medium term, and long term. Short term is, people refer to it as inflow, and medium sort of the mixed, and the long term is the infiltration, the rainfall dependent infiltration. And then I'm just move to simulation parameters. Talk about dates, routing, time steps, etc. Here, and I'm sorry, I'm moving in the interest of time. So you have the here you can make sure you have the units that you want, which modules are running. You don't have the groundwater, for example, or any external flow. You can switch it off. Here you can build the full model, but you only want to run the dry weather. That's an opportunity to have everything in the same place, and you have wet weather parameters, but you're running only the dry weather model with whichever process you use. And I typically use the dynamic wave. That is one time where I use the kinematic. I had a lot of fluctuations, and I wanted to see a cleaner hydrograph, so I went to the kinematic. But I usually like to go with the full solution. I guess this is a clearer picture here. Sorry. The dates. Obviously you select your dates, and I like to start the analysis about one day if I have the luxury before start reporting, give the model an opportunity to stabilize, reach steady state, whatever it may be. We can also talk about the hot start, and that's something that you might use sometimes if you have a lot of stability or conditions where you want to start the model from an already completed simulation. The other thing here are the time steps, and naturally I would use a larger time step for the dry weather compared to the wet weather. The dry weather, I assume, is just steady state. It's going to repeat that pattern, but wet weather is going to vary based on the rainfall events. Reporting time step, the results will be there. The reporting time step is how do you want to display, how many time steps or what resolution do you want. The model will solve here the wet weather based on a 5-minute time step, but you will see a result point every 15 minutes. And that can help with controlling the simulation. I sometimes run it with a coarser time step until I feel comfortable that I reached the solution or the stability or the continuity error that I desire, and then I would switch to a finer time step and get higher resolution. For the calibration and validation, we look at pretty much all values you can think of are produced in the InfoSWM results, whether it's a ratio of flow to full pipe flow to design flow, depth to diameter, or total depth, whatever it is, it's there. So decide on what you want to calibrate to. For dry weather, we look at the flow as well as the depth. Models will always, I mean, I say always, let's say 99% of the time, because I haven't worked on every single model that's out there, but they will underestimate depth and overestimate velocity, because the model, you put an 8-inch pipe at a certain slope, that's what it is. In reality, there are offset joints, there are debris accumulation, there are things that you don't see that make it not, that don't make it a clean pipe. So there is always the model, even the model will almost always show higher velocities and lower depths, and you need to increase those factors, friction factor or whatever other loss factors, Mannings or whatever, to bring the depth up and slow the velocity down. But it's very important to calibrate for both flow and depth, and what you see here is a velocity, a depth versus velocity, and what's in yellow is the observed data, and the navy blue is the model data. And again, it's slightly below in terms of depth and higher velocities, but it's close enough in terms of the pattern, simulating the pattern. Because what happens if when you have a clean pipe model and you're underestimating the depth, it's okay when it's open channel flow, but once it becomes surcharged and you're trying to evaluate conditions of surcharge or overflow, the model might be saying you're okay if you're underestimating the depth, but in reality, you would be overflowing in the field. So you don't want that condition. That's why You don't just model for flow, peak, and volume. You also model for depth. We also want to get the timing right. We'd allow like 30 minutes to an hour between the peak of the model and the peak of the of what the observed data is. So similar
Do you
on the
normally,
wet weather. Yes, go ahead.
do you normally go through kind of a process of we calibrate it to the dry weather and then we move on to the wet
Yes.
weather?
Yes.
Are there any problems ever with kind of conflicting, like you get the flow looking really good and the depth that doesn't look as good, or usually when one lines up, the other lines up?
Yeah. If I'm gonna attempt answering it. If I miss it, let me know. There are, yes, we do always calibrate for dry weather. I want the stable, everything is in the pipe condition. If I can simulate that, then I can move to a more challenging situation. But the second part of your question, where deviation, would you repeat that? Sorry.
That if you get the flow to calibrate really well, but don't necessarily get does the depth always kind of
Yes.
line up really well?
Yeah.
Or
No.
okay.
No, it doesn't. It doesn't.
Oh.
It doesn't always line up really well. There is but typically, and what I tell my team, it's either we need to fix it or we need to explain it why it's not. There might be something in the field that is backing up that line that's not simulated in the model. It rarely works the first time, I guess, if that's the answer to the question. We always have some cases we have to put more effort in it and change conditions in the model to get the match of the field. But if it doesn't match, there has to be an explanation. And sometimes it's a temporary, and those would be the most challenging condition, is like a 2x4 or some debris got stuck for that and it's no longer there. So there is no way to reproduce this dynamic debris or change of condition. And yeah, we sometimes get stuck. But if anybody on the call has something, please chime in and I'll stop. Let's see. All right, let's assume we have a calibrated. Sorry, Ryan, did you have something?
No, there's a couple of other questions, but I know you're pretty close to the end, so I can address those later on. Yeah,
thank you. So after we've calibrated the model, we have a model that represents existing situation or represents what we have. Then we can start creating scenarios, and I really like the scenario functionality. And it goes with I'm sure you've heard the term parent and child. So whenever you have a child of an existing scenario or a scenario you have before, it inherits all the properties, all the data from that, and then you start varying that scenario, but you vary it in terms of the set. So let's say you're upgrading a pump station. I would create a new pump set, say upgrade 1, and assign it to this new scenario, child scenario. This way it's only restricted to that scenario, and I would start upgrading those pumps and varying them. Same thing for a conduit. Let's say you want to upsize a conduit. That's where you would do it. You would create a new conduit set that's a copy of the existing one, and then do it. Because if you change the base set that came with the existing, you're going to change it for anything else that's doing. You're basically changing your existing system. One point that I was that was mentioned to me, one of my colleagues, David King, at some time, and I keep sometimes asking him when I move away from the model, remind me of what you said about that, the IntelliSelect. I don't forget it anymore, but just the IntelliSelect will allow you to change facilities, deactivate. So if you want to replace a pipe, in a scenario and you want to deactivate some facilities, you have to have the IntelliSelect. Otherwise, it'll do it for all your scenarios and it'll be frustrating. You'll go back to an old scenario. Oh, this is deactivated. I've done that. Maybe nobody else does it, but I've done it enough times that I've suffered from it. So remember the IntelliSelection. You can have replacement by basically creating your new conduit set and changing your diameters, inverts, whatever along the same. I like to start with keeping the same inverts but just changing the diameter. Or in some cases, another trick I learned from a colleague is you have your original pipe and then you start drawing pipes that are connecting to the same node. And what's nice about this is you can force the length to be the same. The pipe obviously graphically is longer, but you can type in the length to make sure it's the same as this, but at least you see the two options in front of you. One is deactivated and one is active. Relief, you can extend the line however you want, right next to it with a start and stop points, and vary it and make cross connections between the lines. Sorry, I'm moving quickly. Or storage, just decide if you want to underground storage, you want to drain the pipe into it and then use a pump to put it back after the wet weather subsides, or you want to pump up the storage, or you just want to pump it to storage and say, this is the volume that we need to shave off. Go figure how you do it. There is also inline storage. And get 2 more minutes or I have to stop?
Yeah, no, I mean, I know we're a little bit over. There was one question I did really want to get to, because I certainly don't have a good answer. When you're calibrating to the wet weather flows, do you normally look at just one individual storm, or do you kind of look at the whole kind of multiple storms back to back?
Very good point. Yeah, all of the above in sequence. So I'd look at one storm to get me in the ballpark. And then once I have the storm, I'll start calibrating to other storms. So I like to have 3 storms, you know, at least 3 storms to calibrate the model. And then I would pick 3. So I'm adjusting parameters, RDII parameters. Once I get that, I like to do, I mean, some people would differ on terminology, but that's calibration. I'm adjusting parameters until I get a match within a certain margin of error, up or down, for 3 events. Once I get that, I like to do validation storms. So I pick storms that I didn't use in the calibration and see how close am I. Am I still within the criteria? I'm not going to get the perfect response, but am I still within the criteria for those other events? And if I'm comfortable with that, then I want to run a continuous simulation to say, okay, I've run isolated storms, but I really need to make sure that the model accounts for antecedent conditions. If I have storms back to back, am I able to recover or carry the flow and still represent it correctly? So I would start with the one event to get me in the ballpark. I would test other events, validate against using events I did not calibrate to, and then I would like to run as an extended period simulation and adjust additional parameters to make sure I capture antecedent conditions. Hopefully that answers the question.
Yeah, I think so, and really emphasizing that, you know, there's the calibration piece, but you know, that's not just, we're not just calibrating to one storm or a couple of storms. We want to make sure that it's validated against other storm events.
Yeah, and I would recommend validating annually at least. You know, every season you have a new set of events. Make sure your model is still valid, still works. And coming close to an end here, there is obviously always the reduction, which is achieved by rehab. That's the reduction of INI. And you can modify your area, or because that's not a real area, it's not a stormwater model, it's based on a stormwater model, but you're simulating the openings, the holes, the defects in the sewer that allow this rainfall in, or adjusting the R values. And just final thoughts in terms of the continuity error, I always like to look in, you know, if one of my team comes and says, okay, we have this model, it's done, it's like, have you checked the continuity error? How does it look? And I like to definitely see something below 5%, and oftentimes we're able to achieve below 1%. What you can do is control your time step, reduce your time step to allow the model to allow the solution to converge. And that's basically what you can do with the SWIM engine. But also in InfoSWM, you can control the stopping tolerance, like reduce the tolerance of the depth or where you are in the manhole, as well as the number of iteration. I think the original SWIM engine has a limited number of iterations, but InfoSWM, I believe, maybe you can chime in, and it allows you to increase the number of iterations allowable to converge to reach a solution, reduce the continuity error. I'm done.
Yeah, I do think you're correct in that there are some parameters that you can tweak and help with some of the continuity, in addition to, of course, reviewing your data, making sure that's accurate, things like that. Yeah, I know we're a bit over, so thanks for hanging in there with us, and hopefully you guys found it insightful, and thanks again for joining us and handling a lot of the presentation here. I guess with that, we'll call it. So thank you.
Thank you.